Hey guys, I want to start this off by apologizing because apparently I had to delete some of the videos that I had for AP Physics explanations or private them بالأحرى يعني because apparently like I can't really use some of the material is confidential and I can't distribute. So I'm just gonna, stay on the safe side and use this material that's provided by College Board and is accessible by everyone. So, yeah, without further ado, today I'm solving something from the free response questions of 2016. So, yeah, let's get started. Okay, here, a wooden wheel of mass m consisting of a rim with spokes rolls down a ramp that makes an angle theta with the horizontal, as shown above. The ramp exerts a force of static friction on the wheel so that the wheel rolls without slipping. On the diagram below, draw and label the forces, not components, that act on the wheel as it rolls down the ramp, which is indicated by the dashed line. To clearly indicate at which point on the wheel each force is exerted, draw each force as a distinct arrow starting on and pointing away from the point that it's exerted. So this is your typical free body diagram question, but it's a bit like it's with a twist because they want you to show which force is exerted from which side. So you need to have like a clear understanding of all the forces. So let's start with the easiest force as usual, which is mg. Mg always points downwards no matter if the ramp is slanted or whatever, it always points downwards. And it starts from the center of mass of the object, so from the middle of the wheel. Fn, or the normal force, is the force exerted, let me change the color, by the ramp on the wheel, and this has to be parallel to the surface. So if your surface is like that, it will look like that, your Fn. If your surface is like that, it will look like that, your Fn. So if your surface is straight, it will be straight. But unlike mg, which is always pointing downwards, this has to be perpendicular to the surface. So over here, and it starts from the surface, by the way, it doesn't start from the center of mass. You need to indicate that. So you're going to come over here and it will pass through the center of mass, but it starts from the surface itself. So this is F normal. And then they told you that there's static friction, which is going to oppose the motion of the wheel, which is rolling down this ramp. So this is the motion of the wheel. So the friction must act in the opposite direction. And the friction is exerted on the part which is in contact with the surface. So this is where you should draw your F friction. Exactly like that. So Fn is from the surface, perpendicular upwards. Mg is from the center of mass and going downwards. And F friction is from the wheel itself, the part in contact with the surface. And this friction is static, by the way. Anyways, pointing to the opposite direction of the wheel's motion. When you're done with this, you'd be done with part AI. So for part II, it says, as the wheel rolls down the ramp, which force causes a change in the angular velocity of the wheel with respect to its center of mass? So let's look at the forces and see which one is possible. Is it mg? No, it's always going to be there. It doesn't really have to do with angular velocity or whatever. Fn is as a result of mg. The only external force, or let's say net force, that we have over here is the static friction. So aslan, it's the only force that is valid to use. So the first part of your answer is you say F of static friction, or just force of static friction. And how are you going to explain this reasoning? So this force is acting away from the center of mass, like there's a certain radius away from the center of mass. So it's far enough to exert a torque on this moving, rotating object. So it's causing it to rotate, but it's exerting a negative torque in this case because it's, reducing the angular velocity of this wheel. So all you need to say is that this force simply exerts a torque on the wheel, which decreases its, or the wheel's, angular velocity. Again, if you write this reasoning and obviously this force, you get the full mark. Yeah, also when like a small tip, when they tell you briefly explain your reasoning, they're usually looking for an answer length that's this long. So don't waste your time on the exam writing paragraphs and paragraphs because this is a short free response question. So a sentence that explains like briefly is literally enough. So after you're done with this, you're done with part A. Okay, part B is a little tricky and it's just with the wording. So if you can understand proper English, you'll be more than fine. So you just need to focus really, really well when you're reading this question. You might want to read it twice. I don't know, you might want to pause the video and try to solve it for yourself, but you just need to focus. So it says, for this ramp angle, the force of friction exerted on the wheel is less than the maximum possible static friction force. Instead, the magnitude of the force of static friction, so they're about to tell you the force of static friction, exerted on the wheel is 40% of the magnitude of the force or force component directed opposite to the force of friction. This is very mind-boggling. Derive an expression for the linear acceleration of the wheel's center of mass in terms of m, mass, theta, and physical constants as appropriate. Physical constants usually means like gravity, stuff like that. Okay, let's break this down together. First of all, we write what we know. We can tell that they want acceleration and it has to deal with forces, so we will write our like famous law, F net is equal to ma, or mass times acceleration, okay? And we want this acceleration. What's F net? We need to break it down further. So we know that F net is driving, so the driving force minus resisting, or the resisting force. So this is equal to ma. Then we look at our free body diagram because it's really useful. So it's good to memorize. First of all, what you're gonna want to do is break down mg, the force vector, because clearly something is letting or allowing this wheel to roll downwards, right? So something, one second, is causing this downward motion. Whether it's a force or a component of a force, something is doing that motion. As we can tell, there's no major force over here, right? So there's no major force that's causing this falling or rolling downwards of the wheel. So that means it's simply a component of mg. The one that's pulling down, so this is your theta over here, كده, and this is the one that's going to be away from theta, so it's mg sine theta. This is the component or force component that's allowing this downward movement, or basically pulling it downwards. So with this new piece of information, we're going to go back, and obviously, as we can tell, the opposite, the force that's opposing this direction is the static frictional force. So when we go down and read this phrase again, it said that the friction or the static friction exerted on the wheel is 40% of the magnitude of the force or force component directed opposite to the force of friction. So we just figured out that the force component directed opposite to the force of friction is mg sine theta. And in mathematical like vocab, of means times and 40% is basically 0.4. So now we know that static friction, F static, is 0.4 of basically multiplied by mg sine theta, which makes everything much, much easier. And we know that this specific component is the driving force or force component of this system. So over here, we're just going to plug in. We know that mg sine theta is the driving force minus the friction, which is the resisting force, which is the force opposite to the force that's driving, which is 40% or 0.4 of mg sine theta, simply is equal to ma. Now we solve for a very simply. We're going to divide by m, so we can cross those out and we'll be left with 1 mg sine theta minus 0.4 mg sine theta, which is 0.6 mg sine theta over m. You can go ahead and cross these m's So your answer is 0.6 g sine theta. And that's your acceleration, or what they're asking for in the question. The last part of this question is part C. It says, in a second experiment on the same ramp, a block of ice, also with mass m, is released from rest at the same instant the wheel is released from rest, and from the same height. The block slides down the ramp with negligible friction, so no friction. Which object of either reaches the bottom of the ramp with the greatest speed? So obviously it's gonna be the block of ice, because so they want you to explain it in terms of forces, focus on that. So for the block of ice, it's because it's gonna experience less friction or no friction actually, while the other one has static friction. So obviously ice is frictionless. So this means that there is going to be no resisting force. So the total net force is going to be greater for the ice. So the acceleration is greater. So the final speed and the greatest speed will be that of the block. So this is like a simple reminder, like some notes. So no friction is equal to no resisting force, which is equal to greater net force, and a greater net force is proportional to a greater acceleration and a greater speed. Now for part 2, they want us to briefly explain the answer again, but reasoning in terms of energy. So they said that it's dropped from the same height and from rest. So this means that GH, or the potential energy of both the wheel and the block, are equal. Okay? So this leaves us with the kinetic energy. So if they start off with the same potential energy, this means that this equal potential energy will be converted into kinetic energy. For the block, the only form of kinetic energy is translational kinetic energy, which is half mv squared. For the wheel, so basically I'll explain what they mean. For the wheel, the same potential energy has to be converted to both translational kinetic energy and rotational kinetic energy. So basically it has to be shared, and the speed has to be shared for both. Why is that? A block simply needs translational kinetic energy. What does translational mean? It just moves like that in a straight, like sort of 2D dimension. While the wheel has to move like that and roll or rotate down, and it can't slip. And the kinetic energy responsible for rotation is called rotational kinetic energy, and I will explain these in terms of the rotational terms and everything in another video. But all you need to say is that the same potential energy has to be split into both translational kinetic energy and rotational kinetic energy. So the translational speed of the wheel will be less than the block of ice. So this is the same answer, but in terms of energy, and in the part before you answered in terms of forces. So basically this is the full question, question number 1 in FRQ 2016 from College Board. Please feel free to comment further topics that you want me to explain, and I really hope this helped.